Hello, this is Preeti Singh. Uh, so today we are going to start. We are going to have a look over on the chemical oxygen demand in textile wastewater. Textile industry is a major source of wastewater. Wastewater is a major environmental issue for textile industry. Their disposal is always a matter of great concern since they are considered as quite dangerous source of environmental pollution. Major pollutants of textile industries can be highly responsible to uh, contaminate the normal water bodies. Wastewater, the textile dyeing, then spinning, sizing, resizing, these processes are very extremely water intensive, and wastewater produced is also very extensive. Wastewater treatment in textile industry is such a big concern that 1 kg of just textile production requires almost 200 liters of water. The wastewater is especially harmful because it also contains stress metals. Unfortunately, most of the industrial wastewater from textiles go back into the environment untreated. If left and incorrectly treated, the textile wastewater can cause irritation to skin or harm to the aquatic animals. Chemicals present in the water block the sunlight and increase the biological oxygen demand, thereby inhibiting the photosynthesis and reoxygenation process of water. There are the major pollutants of textile industrial wastewater. These are TSS, that is total suspended solids, then chemical oxygen demand, biological oxygen demand. Color is one of the most major pollutant of textile industrial wastewater. And then acidity and presence of heavy metals is also one of the biggest concerns. Then there are many methods, physiological chemical methods for the treatment of this wastewater. The physicochemical method includes coagulation, flocculation, precipitation, electrodialysis, then flotation, filtration, absorption, and others. Coagulation is mostly applied in the textile industries. Filtration treatment method is effective in removing COD color. The dye is used to impart color is to materials of which it becomes an integral part. The dye wastewaters contain toxic organic residues with the major compounds of phenol derivatives and derivatives, organic acids and benzene derivatives. There are numerous types of dyes which can be classified as acetate rayon dyes, acid dyes, azoic dyes, basic dyes, direct dyes, moderate or chrome dyes, lake of pigment dyes, sulfur or sulfide dyes, and white dyes. Mostly correlation of chemical structure with color can be accomplished in the synthesis of dye using chromogen or chromophore with oxochrome. And other method used for treatment of the water biological methods. Biological methods reduce the biological oxygen demand of the water and they remove organic compounds like organic nitrogen, organic carbon, organic phosphorus, organic phosphates from the water with the help of the treatment through bacteria. The main issue of textile wastewater is the color removal and COD. Color removal is most probably achieved with the process of coagulation, but COD removal is also a big, you can say, uh, kind of challenge to the wastewater treatment industry. But then what is oxygen demand? Any oxygen demand is nothing but it refers to the requirement of oxygen for the oxidation of organic and inorganic matter. Means it gives you the requirement of oxygen oxidize oxidize the organic and inorganic matter by uh, oxidant is said to be uh, and the quantity of oxidant consumed is expressed in the terms of oxygen equivalence. Okay, it is every time represented in the form of ppm of milligrams per liter as O2. The major principle is just that you have to take an organic or inorganic matter, add a strong oxidizing agent. Mainly dichromate is added here. Earlier we used to use potassium sorry, potassium permanganate or hydrogen peroxide, but they were not enough to oxidize the organic or inorganic matter present in the water. Hence, potassium dichromate are used these days. COD is the measure of biological available and inert organic matter that is susceptible to oxidation by strong oxidizing agent. US Environmental Protection Agency specifies that the dichromate reflex method is the only method acceptable for reporting purposes. The advantage in using this method is certifiable results as well as high accuracy. COD is used as is used as measurement of population. It is normally measured in both municipal and industrial wastewater treatment plants and gives an indication of the efficacy of treatment process. COD is measured in both influent and effluent. The efficacy of treatment process is normally expressed as COD removal measured as a percentage of organic purified during the cycle. COD has further applications in power plant operations, chemical manufacturing, commercial laundries, pulp and paper mills, agriculture and animal waste run, environmental studies and general education also. HANA equipment can HANA equipment COD can be used in laboratory or on off or on site. The measurement procedure has been designed to ease the use of personal skill levels. The goal in wastewater treatment is not only CO2 reduction, but also the control of nitrogen and phosphorus, which are responsible for eutrophication phenomena in the natural environments. COD, nitrogen, phosphorus control are performed not only to obey environmental laws, but also to optimize plant. The basic principle here is just you have to take a sample of a known quantity, add oxygen, let the process take place, and determine the level of agent and expressed in equivalence. Thus, COD is only a two-step procedure: digestion and determination. But then people follow some conventional methods or traditional methods like open reflex method, that is open reflex dichometric method, and some people follow open reflex closed method. Sorry, closed reflex. In the open reflex method, you have to prepare the reagents like sulfuric acid, sulfuric sulfate, silver sulfate, and potassium hydrochloride, and you have to standardize it, and then the sample digested. And then after digestion is completed, you have to titrate the excess dichromates with less ammonium sulfate. And the method is closed or calorimetric method. In this, you have to take a dose vial, digest it at 150 degrees, and then you have to measure it Now, the advantage and disadvantage of industry methods. The advantage of closed reflex method is very quick and reliable as compared to that of open reflex method. Closed reflex method have using whereas they are applied by the manufacturer, whereas in open reflex method you have to prepare the reagents, you have to prepare them and standardization method. So it is a very time consuming method to analyze chemist and minimum of maximum of 25 number of samples in just 3 hours. You will get results as compared to the open reflex method creates or produces high amount of organic. The closed method is small that high wherever when minimum amount and maximum amount of sample use is 2 ml. Hence, a um, you can say skills are required. Just dosing of samples, whereas skills are required. Then what the interference due to other solid matters that do not get digested will interfere when you are using open reflex method to because when you shake the flask, it might come, it might interfere with the fermentation procedure. Whereas when it comes to closed reflex method, the undigested part settle down in the and will not into the right part, not interfere in the reading. And most important, will dye color interfere in your reading? The answer here is no. The dye color will never interfere in the COD readings. As the dye comes in contact with the dichromate, it gets readily digested, and hence it will never inhibit a color to interfere your reading. Next, how to take measurements. Measurement with the help of closed to one for sample or one for blank sample in blank sorry and then you have to shake those wires, digest them, and just after they cool down hardly between 10 to 20 minutes, and then you have to measure it photometrically. That's it. What are the contents of these vials? The contents of the vials are same as that is used in open reflex method. The ratio differ. It have an oxidizing agent, it have a catalyst, it have an acidic medium, and a mercuric salt to inhibit the fluoride interferences. Then we at Hanna offer three ranges 0 to 150, 0 to 1900, and 0 to 15,000. So you might have a question that what if my sample doesn't fall in this range? You just sample the DI water to 10% or 15%. It will fall in the range of the vials and you can use the vial accordingly, measure the COD. And once you get the result, multiply with the dilution factor. Then we offer the vials that are applied to EPA method or to ISO method. No matter method you follow, use any vial for COD measurements that we had Hannah. Then these pre-dose vials are extremely safe. They do not burst or they do not shoot the cap when you use them. Hence, there will be an accident-free COD measurement when you choose Hanna COD vials COD measurements. So these are the COD essentials that we offer. That is photometer or spectrophotometer digester, which can digest almost 25 number of samples at a time, and then reagent vials. If you could see on your screens, the digester have a screen which shows the temperature, the time lapsed, and it is the temperature is automatically maintained in this digester. And most important and most feature of the digester is after the time of 2 hours or whatever is required is lapsed, the digester switch off and will start pulling the vials. Hence, even if you forget that you have kept this vial for digestion, it will not harm your readings. There will be no interferences in readings. You will just have to take the vials and start take the readings, as the readings will be accurate. So, for any questions, mail us on application@hannainst.in, and for any inquiries, mail us on marketing@hannainst.in. Thank you, everyone.